and then we're going to restart again, but we're going to be a bit short this time, okay? Então, senhoras, prezados, boa noite. É com muito prazer que a gente tem a honra de superar esses desafios do dia a dia. A gente começa essa edição, essa nova jornada do React 8 Congress, superando desafios. Então, sejam todos bem-vindos. Declaramos aberto a sexta edição do Simpósio React e a primeira edição do React 8 Congress. Nós viemos crescendo aí nos últimos anos, numa jornada de primeiro, segundo, terceiro, quarto, quinto congresso, numa crescente absoluta. E esse ano nós elevamos, nós chegamos ao patamar de congresso, chegamos ao patamar de internacional e trazendo aqui os apresentadores, palestrantes de peso que nós temos, ok? E de já agradecendo todos aqueles que construíram todas as edições dos simpósios anteriores, todos os palestrantes, todos os autores, e todo o público, naturalmente, é quem faz o simpósio existir. Todos vocês que se inscreveram, se submeteram ao trabalho, a gente agradece grandemente. E aí, na linha dos autores, né, tivemos esse ano recorde, né, de trabalhos submetidos. A partir de amanhã, a gente começa a exibição dos trabalhos no nosso canal, React Universe Play, e a gente reitera o agradecimento aqui. E nessa linha dos trabalhos, a gente agradecer muito aos avaliadores que dedicaram tempo, dedicaram atenção, dedicaram seu conhecimento em colaborar com a avaliação dos trabalhos. Okay? Então, a gente quer aqui agradecer novamente, certo? E dizer que é com muita satisfação que hoje nós recebemos o professor Andrea Grilli para debutar, para abrir este simpósio com a sua palestra e vem trazer para a gente os avanços, né, os impactos na aplicação de materiais. Eu sou Andrea Grilli, professor da Universidade Politécnica de Maché, né, reconhecido especialista em engenharia rodoviária sustentável, né, e atua no desenvolvimento de soluções de baixo impacto na infraestrutura viária, pesquisas relacionadas à reciclagem, pavimento asfáltico. Ele vai trazer para a gente hoje a palestra intitulada Low Impact Strategies of Sustainable Road Construction and Maintenance. Então, gostaria de agradecer muito ao professor Andrea Grilli. Andrea, thank you very much for your attention. Just give a last check on our stream. Guys, on YouTube, can you please check if audio and video it's okay?
Okay, the audio should be okay.
Okay, just let me check the YouTube. Just a second.
Yes. Just check if anyone can see my screen.
Okay. Just check. Just 1 second.
Yes.
Okay, okay, Andrea. We have we have we have a stream working properly. Uh, just check, Andrea. We have a PP. We can see your slide, but we also have a PP on screen. That's over your projection. Yes, you can check it out. I think it's close. It's work. Yes.
Okay. Okay.
Oh, now it's completely okay.
Clean.
It's work
Yes.
clean. Clean. Quite. So thank you very much again. I'm so sorry. The actual Congress is kind of this. We are overcoming challenges. So thank you very much. And now we receive Professor Andrea Grilli from Universidade Politecnica Marche in Italy and Pona. You're very welcome. And you have the words. Thank you very much, Andrea.
Thank you, Jose. Good evening to everyone, and thank you for the invitation at the first React World Congress. My lecture opened the international conference, so it is an honor, and I would like to thank the organizing committee, the director, Professor Jose Renato, who first contacted me. It is also a responsibility because this lecture set the stage and guide the participant into the conference main topic. Before entering in the technical part of my lecture, I would like to explain how I have interpreted the invitation and why I decided to build this presentation in a specific way. My education background is in road engineering with a specific focus on road materials and pavement design. However, I am aware that the audience is broad and heterogeneous, including students, researchers, academic, industry, with different backgrounds and expertise. Some of you may work directly with infrastructure, many others may not. Therefore, my objective in the first part of this lecture is to create a common ground for everyone. I would like everyone to take away at least one good idea, even if road engineering is not your field. For this reason, I will not start immediately from asphalt mixture and maintenance method. This topic will come later. Of course, they are essential. But if we want to understand why low impact strategy for road construction maintenance is an important topic, we first need to clarify some basic concept to make sure that anyone can follow. Therefore, the first part is on sustainability, part two on road management, and how to implement sustainability into road management, therefore, what to do at the decision level. Part three is on specific applications, therefore, what to do on the design level. We can say that sustainability is the compass, give us the direction, is the North Star. Management system is the container, and sustainable materials and technologies are the tools inside the container. So let's start from the part one on sustainability. I will introduce the general context, then I'll move to guiding principle. We will talk about sustainability from the definition to limits, dimension, culture, the ONU Agenda 2030, which contain really the most important concept for human being and for our planet. Afterward, we will see policy frameworks and the procurement, talking about the Paris Agreement in 2015, and then in detail what is going on in Europe, in Italy, as a case study, because that is the situation, of course, I best know. So before addressing sustainability in road material, we should acknowledge that complex problems rarely have a simple solution. Apparent simplicity is often the result of an incomplete understanding of the variable, of the interaction constraints, the long-term consequence. Simplified and easy solution can be misleading, especially when they ignore the structure and the dynamics of the system. Therefore, our goal is to understand the complex situation to make responsible and technically good decisions. Specific words such as sustainability are often overused and sometimes abused, particularly for marketing purposes. Greenwashing is really a risk, and I would like to focus on the precise meaning of certain terms and examine the terminology in depth so we can better understand and address complex situations in our everyday life. The general topic of this Congress is ambitious, is very, very good. It is not a neutral title, and it asks us to connect sustainability with material, energy, science-based innovation as drivers for real development. In other words, it asks us to move from principle to application, from values to method, from scientific knowledge to technological decision. I also check the topics of the React event in the past. So I understood the React trajectory, and in 2023, the event focused on decarbonization and economy, energy, environment, and then in 2024, technology, energy sources once again, and the need to overcome global challenges, and then artificial intelligence as the sustainability as a path toward inclusive growth. And today, this year, the focus on materials, energy, sustainability as science applied to technological development. They are not isolated topics, they form a trajectory, and they bring us to approach to a fundamental question. And the question is, how can technological development respond to global challenges without increasing inequality, environmental degradation, and long-term risk? I want also to underline two expressions I found from the previous topic in the past. Vencer os desafios globais and crescimento inclusivo. These expressions are very important because they remind us that sustainability is not only technical, but it is also human. Therefore, we are speaking about the ability of the society to face global challenges while creating opportunities that are not reserved only for few. So we can start from the definition of sustainability, and you can see in this slide the classical definition: sustainable development meets the needs of the present without compromising the ability of future generations to meet their own needs. For the first time, this definition introduced the core idea of intergenerational responsibility. Therefore, sustainability is not only about protecting nature, but it is about governing development. Considering a more technical approach, we can update this definition, and I will formulate it in this way. Sustainability is the ability to make progress last without exporting unacceptable ecological and social costs to the future, to other places, and to more vulnerable people. We must realize that nature is a, a system of interconnected components and cycles. They are in equilibrium, but just a small change can produce strong responses, and we cannot disturb this equilibrium. So human activities take place within biophysical boundaries that control the climate stability, biodiversity, land use, water, and air quality. The scientific evidence show us that human development is pressing against ecological and climatic limits. From here, the concept of planetary limits help us understand that not everything that is technically possible or economically profitable is also suitable. Traditionally, we often describe sustainability through three dimensions: environment, society, and economy. The environmental dimension defines the limits within which human activity must operate. The social dimension reminds us that development must serve people, improve quality of life, reduce vulnerability, and promote inclusion. The economic dimension is essential and means using resources efficiently over time and avoiding the transfer of hidden costs to the future. Therefore, sustainability is a decision framework with three main pillars. Sustainability can write the criteria to select specific project and research. We can also try to understand the relationship between sustainability, society, and economy. They can be organized in different ways. We can distinguish two different main logics. The first, the economy moves sustainability. A low impact solution spreads when it becomes profitable, efficient, and competitive. In the second, sustainability guides the economy. An informed society defines an environmental objective and then use regulation, procurement, and economic instrument to make that objective viable in the market. This is why sustainability is also a cultural and educational issue. Only a society, and the society I include engineer, designer, student, researcher, industry, only society able to understand long-term consequences can orient economic tools toward public value. Sustainability has culture and education. Technology are necessary, of course, but they are not enough. A society does not become sustainable simply by adopting more efficient machine or new material. A society becomes sustainable when people understand sustainability as a shared responsibility, when designer, company, university are expected to consider the long-term consequences of their decision over time across territories and for people. This education dimension is especially important in this context, in the Congress like React, because many participants are students and young researchers. We are not only learning techniques, we are learning how to interpret problems and how to address and evaluate solutions. We are learning what kind of professional responsibility belongs to science and technology. In this context, we can talk about the United Nations Sustainable Development Goals. The development goals adopted in 2015 provide a universal and integrated framework for strategic and political planning. They bring together the economy, social, and environmental dimension of development, and they offer a common language for governments, institutions, company, and society. Really, this process started in 1992 with the Earth Summit in Rio de Janeiro, in Brazil. In the 2030, the ONU agenda influence national policies because it provides a common language, a structure of goals, a system of indicators, and a mechanism for international reporting. However, the sustainability development goal do not define technical standard, so they are not mandatory. They give us the direction. In 2015, the Paris Agreement became the global framework through which countries coordinate their efforts to address climate change, reduce emission, and strengthen adaptation and resilience. Paris Agreement works in a different level. Paris Agreement is the global legal architecture for climate action. The Paris Agreement established a procedural framework based on progressively more ambitious targets that are called nationally determined contributors. They are national climate commitments through which each country defines how it intends to contribute to the goal of the Paris Agreement. The data, progress, and action obtained by each country are described and reported through transparency mechanism, and the global stocktail periodically and globally assess the collective progress toward the goal of the Paris Agreement. Therefore, countries are not only asked to declare climate ambition, they are required to update it, to report on it, and compare collective progress over time. Let me now move from the global framework to the European interpretation, because it is useful. It is a useful example of how sustainability is moving from principle to procedure. The European Green Deal defines sustainability as a new growth strategy, an economy that is modern, resource efficient, with no net greenhouse green emission by emissions by 2050. The European climatic law makes climate neutrality a binding objective. In this case, this is a binding objective for the European Union and for the member states. Sustainability becomes, therefore, part of how infrastructure is selected, financed, and evaluated. In Italy, one example of this operational shift is represented by the Italian minimum environmental criterion on road infrastructure. We call it criteri ambientali minimi strade, so Italian minimum environmental criteria for road infrastructure. This is the implementation of the European Green Deal in Italy. And this regulation transform principle into practice. The CAM strade translate sustainability into technical requirement related to lower temperature technology, recycled material content, environmental reporting, life cycle thinking, and performance criteria such as service life, noise mitigation, and solar reflectance in specific contexts. So sustainability is no longer a cultural aspiration or an ethical orientation. It is becoming a contractual and technical requirement. I give you some example. Nowadays, the CAM strade impose a reduction in production and lay temperature of the asphalt concrete. In urban area, we cannot lay and compact asphalt concrete at a temperature higher than 120 degrees. So we reduce the temperature. About the recycled material, in the past, we had a maximum amount to respect. So the regulation told us no more than, for instance, 20% of recycled material. Nowadays, with the CAM strade, with the Italian minimum environmental criteria, the regulation is exactly the opposite. Nowadays, the asphalt concrete must contain at least a certain amount of recycled material. For instance, 15% for the wearing course, 25% for the binder course, and 35% for the base course. So the approach is completely changed. However, our work is not yet complete. I think we are in the good way, but our work is not yet complete, as several aspects still require further consolidation before they become common practice. We need to wait a gradual transition because the road industry sometimes adopt conservative approach. We still need technical specification and design procedure that can fit better to the new material and to the sustainability concept. However, we are in the good path. The conclusion of this first part, sustainability is a decision framework and that help us decide which alternative provide the best balance between technical performance, environmental impact, cost, social benefits in short and long term. In general, the Sustainable Development Goals provide the development compass. The Paris Agreement provides the climate commitment. The Intergovernmental Panel on Climate Change provides the scientific evidence, and the national laws, design procedure, and specification must transform this principle into action. So we can move right now at the second part of my lecture. Now we are going to transfer the general concept about sustainability into the infrastructure context. We will talk about technical tool to manage decision for road pavement, which is the bridge to the application of sustainable techniques. According to the IPCC, greenhouse gas emissions increased by 70% between 97 and 2004. The average annual emission in 2010-2019 was higher than in any previous decade, and the transport is one of the major contributors to climate change. So what can we do? Road consists of material, building, require energy, transport people, connect people. They are part of the territory and they are expected to last. Therefore, road infrastructure is one of the most concrete place where material, energy, and sustainability are tested every day. Generally, we talk about sustainable mobility. Um, we associate it mainly with vehicle, electric cars, alternative fuel, transportation. However, mobility does not happen in air, it happens on infrastructure. Therefore, there cannot be sustainable mobility without sustainable infrastructure. For asphalt pavements, sustainability should be interpreted as a measurable balance between performance and impact along the service life. So, performance and impact along the service life. We need a system that make sustainability continuous, measurable, and operational. We have to transform sustainability from the general principle into a continuous practice of infrastructure management. Technology, therefore, the concept is that technology must be inserted into a border strategy because they become truly transformative only when they are embedded in a decision system. So technology should not be interpreted as an isolated solution. And I invite you, do not think in terms of one-to-one substitution in a project, as sustainability does not mean replacing a traditional technology with a sustainable one, or at least is not only that, is change the design approach. So for this reason, I can explain the title of this lecture. Low impact strategy mean a coordinated set of choice to reduce the overall impact of infrastructure. Sustainable road construction includes materials, of course, but also service life, and therefore the future impact are already decided during the construction. And then maintenance. Maintenance is the way sustainability is preserved over time. A pavement management system is really a container of a set of tools of technology and method, and the management system can assist decision makers in finding the optimal strategy for maintaining pavement in a good service condition over a given period. The most important word is system. System means a rational connection of coherent action, data flows, responsibilities, and decision. So management of a road network is not only maintenance, is create a system. A PMS, pavement management system, help the road agency, move from reactive to proactive management and from isolated repairs to strategic maintenance. How can we demonstrate that pavement management system is useful? I tell you, a pavement management system is useful because it helps answer the fundamental question on pavement management. So why should we prefer a specific strategy? The objective must be explicit. So the motivation. When should maintain be performed? The right time is very important. The right time is when maintenance produces the highest value or keep the highest value over time. So that let us think to reactive and proactive approach. Where should maintenance be performed? The worst payment is not automatically the first priority. Depends on several parameters. For instance, the traffic volume. Therefore, priority. The agency must fix the criteria to identify the priorities in the road network. And then the road agency can also evaluate several different scenarios and decide the best one. How should maintenance be performed? The technique must be selected because it responds to a specific problem and objective. So we must select the technique depending on the type of the distress and the performance we want to reach. How much should we invest? The issue is the initial investment and the value we maintain over time. So life cycle thinking. And finally, who is responsible? A PMS defines role and responsibilities. Therefore, fix the organization. The pavement management system workflow didn't change over time, is stable over time. So there are several functional phases from gather information, define the priorities, select the type of the maintenance, elaborate the maintenance planning, and then the application. And then once again, we can get new data and implement the informative database. The PMS works in two levels. The network levels is where key administrative decisions influencing the overall road network are made, and the project level is where technical decisions are made for specific area. The two levels must communicate because a project is one decision inside a network strategy. And in this figure, you can see just an example. On the left, the condition of the network. On the right, a specific design for a specific road inside the network. Particularly, this is the network of the Republic of San Marino. Originally, pavement management system was mainly focused on pavement condition, maintenance, budget. Today, it can also include comparative environmental social impact, accident analysis, energy life cycle value. Therefore, sustainability becomes part of the pavement management by expanding its objective. What has changed is the way we feed, govern, and use the maintenance system. Spatial database can help connect data through location, and they are part of the information architecture of the pavement management system. The digital tool implements this decision cycle using graphic and analysis tools. The graphical tools help us to understand, to explain some specific strategies and decisions. The best PMS is the one that the agency can maintain, update, and use year after year. Of course, a motorway agency can use more sophisticated management system. However, also local agency must use pavement management system to organize their activity. They just must use a tailored management system, but they must use a system. A system must be technically sound and sustainable. When resources are limited, the pavement management system is even more useful because it helps to optimize the expenses, it helps the agency track action and improve resource allocation. The objective is also to create a better interface between technical rationality and decision making. A good PMS allows decision makers to understand the consequences of alternatives, allow technicians to explain why a certain strategy is preferable, allows agencies to communicate to citizens how public resources are used with greater transparency. The application of sustainable technology together with performance evaluation monitoring generate knowledge. A successful application can lead to informed replication, while a bad one provides a clear understanding of the causes of failure. So when we start learning from the information gathered, we improve the method, moving from a reactive approach to a more proactive and efficient one. The TMS changes what happened even after the repair or the emergency. Even an emergency becomes information, and it is the first step toward management. So we can go to the conclusion of the second part. The pavement management system organizes activities, record experience, support transparent decision making, and makes design and maintenance more efficient. The pavement management system is the place where low impact technology stop being only technical options, and become part of the infrastructure policy. It is also the place where sustainability can be demonstrated. Pavement management system makes sustainable technique systematic, measurable, and repeatable strategies. So now we can move to the third part of my lecture. And now that we know how work a management system, we can talk about techniques. And I divided them into three main categories: recycling and low temperature technologies, low noise road pavement, and cold road pavements. However, we are ambitious, and a single technology is not enough for us. So we aim to integrate an integration of them. Therefore, we will end the analysis combining several applications in road pavement schemes. So about recycling, a low temperature technology, we can distinguish cold recycling, particularly cold central plant recycling. The mixture are produced in a mix plant. Cold in place recycling involving only asphalt concrete. Full depth reclamation. In this case, the recycling process involve asphalt concrete and the granular material used as foundation layer. And then we have the warm recycling. So we can produce recycled asphalt concrete at lower temperature. We can reduce the temperature between 20 and 40 degrees. Therefore, from about 160 or 180, we can reduce at 120, 140. We can compare the different techniques. There is not one technique absolutely better than another. Depends on the context of the project. Of course, cold recycling do not need heating system. So we work at ambient temperature. We can use up to 100% of reclaimed asphalt or recycled aggregate. Using the technique in field, we avoid also the transportation, and we can get fair performance. Of course, if we produce the mixture in a mixed plant, we can get higher performance because we can control exactly the production. Warm mixed asphalt use temperature ranging between 120 and 140. Generally, in Italy, we use no more than 50% of recycled asphalt, but we can reach very, very good performance. Lower temperature results in lower energy consumption, reduce emissions, reduce work and exposure, and improving also the working condition for the crew. The constituent material are reclaimed asphalt, recycled aggregate, but the key is the binder. We use bituminous emulsion and foam bitumen. These two materials allow to reduce the viscosity of the binder at ambient temperature, so we can produce the mixture using cold and wet aggregate. I skip some slide to, yes, to be in time at the end of the presentation. So this slide shows the conceptual composition of pavement mixture, and you can see on the y-axis the cement dosage, and in the x-axis the bitumen dosage. And we can find in the central part of this figure the cold recycled mixture. They can use 100% of recycled materials and no heating. We can distinguish cement bitumen treated material. These mixtures are the most used in Italy, and the idea of this material start from cement treated material. Start to with the aim to reduce the brittle behavior of a cement treated material by introducing bitumen. And then you can see also the bitumen stabilized material. This kind of mixture is probably the most used in Brazil, and the idea behind the BSM is to improve the shear properties of an unbound mixture. I am also the co-leader of an international group, the Task Group 1, the Realm Task Group 1, on performance-based evaluation of cold recycled asphalt mixture. And we just conclude few months ago a review, a critical review from uh, the colleague in the group, comparing the state of the art of cold recycling in our countries. You can see Italy, Canada, Brazil, Poland, and USA. And we conclude that generally cold recycling can be considered as a recognized technique for road construction and maintenance, and is used worldwide. However, its application is generally hindered by limited experience of road authorities. So the research field, researcher must help road authorities to implement these techniques. A distinctive feature of cold recycled mixture is the requirement of a certain curing period to develop the mechanical properties, strength, and stiffness. The development of curing process is influenced by material-related factor, construction-related factor, environmental-related factor. Therefore, it is not absolutely not an easy task. When bituminous and cementitious binder are employed, the curing process results from different mechanisms, and that involve emulsion breaking, moisture loss, hydration of cementitious compound. These three mechanisms occur at the same time with different weight, and they change their influence over time. So they are tightly related among them, one influences the other one. Moisture loss ensures bitumen setting and bonding between bituminous mortar and coarse aggregate skeleton. Hydration of cement chemically change the pH, chemically accelerate the emulsion breaking and absorb water, so reduce the free water. Dehydration require water, and bitumen can contain hydration product. So all these mechanisms are happen all together. In this slide, in this figure, you can see the mechanism. what's happened during the curing. After the mixing, the mixture is composed of aggregate, water, bitumen particle, and cement. Aggregate and cement particle, you can see it on the left, are wet with water, and there is not contact between aggregate and bitumen particle. But then, at low relative humidity, the drying start. The evaporation rate depends on several factors. And when the drying start, the distance between bitumen particle decrease and flocculation and coalescence start. The emulsion break and the bitumen setting start. Bitumen take the place of water, the second figure, and mechanical performance improve because bitumen take the place of water between the aggregate. For lower moisture content, the radius of the connected water skin decreases and increase the mastic sanction. There was an interesting study developed in Brazil, in São Paulo, that investigate on the matrix sanction. And then there is the hydration, the cement hydration effect. The chemical reaction take place during the hydration of cementitious binder, and it requires the presence of water. From this slide, from this figure, you can understand the evolutive mechanical behavior of cold recycled mixture. Particularly, we can assert that stiffness increases as curing time increases. The higher the curing temperature, the higher the stiffness rate. You can see the red line. The red line are specimen cured at 40 degrees, and you can compare the red line with the green line. The green line represents specimen cured at 20 degrees. So you can see different curing rate. And the blue one represents specimen at 5 degrees. But after a certain time, more than 50 days, we increase the temperature from 5 to 40 degrees, and the stiffness start increasing once again. So the evolution depends on temperature, depends on water evaporation. Another specific characteristic for cold recycled mixture is the temperature sensitivity. Thermal sensitivity increases with increasing reclaimed asphalt content and decreasing the cement dosage. So cement inhibit the thermal sensitivity. However, in the first figure, we can compare the cement bitumen treated material, so using bitumen and cement, in comparison with a traditional asphalt concrete. And we can see that the temperature sensitivity of cement bitumen treated material is really lower than the temperature sensitivity of asphalt concrete. And then can be really an advantages if we think about the climatic change and the higher temperature that we experience right now during this period. Another important task for cold recycling is apply a volumetric approach for the mix design. During the mix design, we can measure the voids filled with liquid. In this way, we can measure, we can monitor the degree of saturation of the mixture. The water is very important because facilitate the compactability of the mixture, but we must control the degree of saturation. Then we must also measure the voids in the mixture because the volume of air and the volume of water influence the mechanical response of the material. So we must control the non-structural part. And from this slide, you can see clearly the evolution of air voids during the compaction. The blue curve, air voids reduce as compaction increases. But we can also see the red arrow, the other curve, which represent the voids filled with liquid, and we can see that the saturation level increases as compaction increase, and when void filled by liquid approach to about 85%, water and fine start flowing out of the mold, so we cannot reach this value of saturation in field. So we can use these results to fix the optimum value of water content. As I told you, the air voids influence the mechanical properties. The stiffness modulus can be considered linearly dependent on air voids at all cooling conditions. 1% increase in air voids lead to a reduction of stiffness modulus of about 900 megapascal. It is about 10%, so a lot. Even more if we talk about strength. The strength of coarse and air show a linear relationship. 3% increase in air voids lead to approximately a halving of strength. Now we can move to the second material, warm mix asphalt. We have not so much time, so I'll try to be fast. We can use three methods to produce warm asphalt mixture. The first method uses temporary modification of the physical state of the binder. So water is used to temporarily reduce the apparent viscosity of the binder. The second method considers the modification of the rheological properties of the binder. Typically, it uses organic additive, synthetic wax, or viscosity modifier, vegetal oil, and so on. The third method considers modification of binder aggregate interaction using typically chemical additive surfactants. We suggest, we proposed a protocol to study warm mix asphalt additive, and the study start with the chemical identification of the additive. So chemical analysis can address the identification of the additive and support the prediction of its behavior in the mixture. Then the second step, we can measure the viscosity, so the effect of the additive on bitumen viscosity. Then the third step, we can check the adhesion, the affinity between binder and the aggregate. And finally, we can investigate the workability and the strength of the asphalt concrete. In this slide, I just show you an example of chemical identification of additive. I am a road engineer, so I have some colleague from the chemical department that did a lot of tests on that, and we identified several families or categories of additive, specifically containing nitrogen, imidazoline, amino groups, or aliphatic change and aromatic rings, aliphatic group or phosphate group, and other additive with amino and ester functional group. They are similar but work in a different way, and we tested a lot of additive in the bitumen, and we evaluated the effect on viscosity. For instance, the additive M and F act as a viscosity reducer, whereas additive T and L seems not to influence the viscosity behavior. However, the additive L and T, which contains amines, reach good adhesion value. So the behavior is completely different between viscosity reducer and surfactant. We also investigate the workability and the strength of the asphalt concrete, and we found that the additive, which mainly contain aliphatic and aromatic functional group, has required a higher compaction energy, while the compaction energy value tended to decrease as the functional group that influence the affinity between aggregate and bitumen move from phosphate and ester to amino functional group. The additive, which includes amine, also achieved very good strength results. One key important factor is the asphalt mix facility. If we want to increase the reclaimed asphalt content, we need to improve, to update the asphalt mix facility using, we identify three main categories: batch plant with a parallel wrap drying drum. We can reach 78% of reclaimed asphalt. Concentric double drum dryer, we can reach 50-60% of reclaimed asphalt. And dryer drum equipped with a recycling ring. That is in Italy the most used, and we can reach 40%, 50% of reclaimed asphalt. Talking about cold materials, material that can be applied at ambient temperature, we can use slurry surfacing. You can see some picture. This picture come from Brazil. A friend of mine, Luciano Pivotto, from the University of Santa Maria, collaborate in another international group, and he shared some experience from Brazil, and the slurry surfacing is in use and can be defined as a mixture that is characterized by a slurry state that evolves in a solid state during the curing process that take generally from half an hour and 12 hours. This can be a solution in specific contexts when we don't want to heat the material. We had experience talking about low noise road pavement. We had experience and design porous asphalt, a new generation of porous asphalt, including 15% of reclaimed asphalt, and produced at lower temperature, 120 degrees, so warm porous asphalt with reclaimed asphalt. The target air voids was about 20%, and we also investigate different additive to improve the mechanical property. You can see here an example of the infrared spectrum for additive. You can see amino groups, aliphatic and aromatic groups from different additives. Well, we obtain good results on average in dry condition, but in wet condition, the action of water influence a lot the performance. And we found that the additive containing chemical surfactant additive show higher raveling resistance. Talking about, once again, low noise road pavement, we can use stone mastic asphalt with crammed rubber. We use the dry method, so we can introduce crammed rubber directly in the mixer, in the mixing chamber. Generally, the amount ranges from 1 to 1.5% by mass of aggregate, and the expected tire road noise reduction is between 1 and 3 decibel. On the left, you can see the grading envelope of the crab rubber, 100% passing the sieve 0.6 millimeter. But the crab rubber is almost all retained at the sieve 0.075. And then talking about cold road pavement, we can select non-black pavement or clear pavement. There are several binders already available in the market, but they look similar, but they are very different in the composition and in the mechanical behavior. Here you can see some example, one with a low amount of asphaltene, modified with SPS polymer, and other binders show a spectrum like an aromatic polymer, suggesting a synthetic origin. Some contain natural waxes, and that generate, you can see from this slide, completely different behavior. You can see the complex modulus and the phase angle that describe the mechanical behavior of this binder at different loading frequency. You can see some application on the left in a tunnel to improve the lightening of the tunnel, the visibility. And on the right, the application for a bicycle lane to distinguish better the lane for the bicycle. For the rural road, we can use surface dressing, at least one layer of binder and one layer of chipping, but typically we use a prime coat and then 3 layers of aggregate and 2 layers of binders. You can see that the pavement, we can harmonize the pavement and the road in the country using a natural color of the rock. And then the last proposed solution for urban area, structural soil as the foundation of the road pavement. Structural soil consists of 2 complementary components, a rigid stone framework that provide a load-bearing capacity required for engineering application, and a soil matrix that support root development and tree growth. They are particularly, this material is particularly useful in urban area, if you want to regenerate the natural context of a residential area. However, as we said at the beginning, sustainable pavement is not a substitution one to one, one traditional to one sustainable, but is a new way to approach to design the road pavement. And here you can see, for instance, for principal road, some example on how to use alternative material. You can see you can select different material for the surface, warm recycled mixture, porous asphalt, stone mastic asphalt with crab rubber, depending on the objective of your project. For the binder course, warm recycled mixture asphalt or cold recycled mixture. For the base, cement treated materials, cold recycled in place. For the foundation, construction and demolition waste, cement stabilized material in situ, and lime stabilized soil. So there are a board of alternatives that we can combine and we can measure. Of course, we can select the best solution considering the performance, so pavement design, and considering the life cycle assessment. Here you can see some other alternatives for urban routes. So maybe we can select for the superficial layer stone mastic asphalt with crab rubber to mitigate the noise, or maybe we can select clear asphalt mixture to mitigate uh, the urban heat island. For the binder course, we can use cold recycled mixture, and for the foundation, for instance, the structural soil, if we want to create also a green area close to the pavement with nature, with trees. And for rural road, we can select surface dressing or maybe warm recycled mix asphalt, slurry surfacing. We can select different material depending on the purposes. And once again, for the binder course, warm recycled mix asphalt or cold recycled mixture. So we have several options, several alternatives. We can draw different scenarios and we can decide the best project. So we are landing to the conclusions. Sustainability is a framework that guides the selection of materials and technology by considering performance, environmental impact, cost, and social value over time. Road agency must implement a pavement management system to assist decision makers in finding optimum strategies. Pavement management system must integrate sustainable techniques to make them part of systematic, measurable, and repeatable strategies. Many sustainable techniques for road construction and maintenance are already known, studied, and validated. However, the main problem is implementation. So, habit, standards, risk perception, lack of performance-based culture, fragmentation between research and practice, and insufficient long-term planning. So the research field must help and work with the public administration to improve this this key point and to spread the sustainable technique. So, thank you for your attention. Muy obrigado.
Thank you, Andrea.
Thank you. Thank you. Thank you, Jose. Thank you.
Oh, okay, very good. Good.
I hope to respect the time.
Oh, of
We,
course, of course.
we,
It's very,
we are in time. Okay.
it's quite good. We just have to thank you very much for your comprehension about our links. And
Oh, it doesn't matter.
thank you. And as we had that little problem, we just gonna open for few questions. Just let me check here on chat what we have on this question. E agora, pessoal, a gente tiver perguntas, tá bom? Podem enviar no chat, vou pegar aqui as que nós já temos. Tá? É, e aí vou passar aqui para o professor Andrea Grilli. Obrigado. Professor Fernando, você está na agulha já, certo? Então, podem ficar à vontade. Vou pegar aqui. Professor Andrea, let me see. Our public is asking, really, asphalt is magic words. I really, I really didn't realize how many things it's related to asphalt and pavement and the road overall, and we really have a word of the concern about asphalt. And let us know on your research what is the main challenges you face nowadays and in this field of research. What's the biggest problem?
Yes. I'm sorry, my camera seems not
No,
to.
don't worry. No,
I don't.
it's fine. It's fine.
I don't know why. I try to.
That's this request.
Okay, so we have to face many challenges as in any field, but probably what I think is that we reach a good level of expertise. So really, we can use sustainable material. The recycling technique uh, are now very good. So we are out of the experimental phase, but the main difficult is to spread the techniques worldwide because the still right now the public administration do not trust enough on this technique. They are conservative. They don't want to change their method. So we are struggling to, and we are forcing them to change their design method and the specification of the material. However, the direction is very clear, and as I show you, also the Italian government adopt a specific regulation to improve and to force the public administration in using sustainable material, to treat new material to in several aspects. So recycling, but also long-lasting performance, mitigation of noise, reduction of urban heat island. So there are many topics. Therefore, now we have the law, we have the technique. Now we must to implement the technique in the common practice, so in the state of the art. So probably that is the main challenge nowadays.
It looks like it's a cultural problem. We have technical
Yes,
issues.
yes, that can be also a cultural problem, and that is why the React conference is very good and is very timing, because we can spread our knowledge and maybe people can trust on that. We are talking with researcher, but also students. The students will be the designer of the future. So I really trust on them. We need to change, yes, the approach and the culture. So we can do that using the education.
Really, really. Indeed, here in Brazil, we have a lot of concerns about asphalt, but the main one is if we have some holes, if it's there or not, if we have asphalt or not. It's quite hard to think about what kind of asphalt, what kind of binding, what kind of if it's urban or if it's rural, you are use the kind of asphalt. Noisy, it's a quality, is a property that's misunderstood approach, and in the tire, use the tire is usually with some
Yes,
good
yes.
results, and I think, and we see, I'm so sorry, I forgot to get something here. The sec, uh, Eleni is saying, listen here, what shall I say? Thank you so much, Professor Andrea Grilli, for delivering such a captivating and impactful talk. I'm so grateful for opportunity to learn from you today. Thank you very much, Alan. Alan Botelho is with us on the YouTube chat, and is thank you very much, just as well to as I
Thank
do
you.
as well.
Thank you.
So, Professor Andrea, what opportunities we have for research from now on? You know, what are you doing and uh, in research today that we can focus on improving?
Yes, talking, for instance, about cold recycling, I show that peculiarity of cold recycled mixture is the curing period, the curing behavior. So this material need time to reach the definitive strength, the definitive stiffness. So I think research must work to accelerate the curing process and therefore to get faster the final, the definitive performance. But I want also to answer to your previous question when you talk about the pothole, because I know that when people talk about asphalt pavement, they generally talk about pothole on the road. Uh, I want to say the research, there is one material for every type of problem. I show you low noise road pavement, clear pavement, um, long lasting pavement. There are several types. But when we have a lot of pothole, I would suggest not to looking for new material, but I would suggest to the road agency to start recording the pothole place and start to learn for the degradation of the pavement. So the agency must start to record to record where the problem is, when they apply the repair, when they apply the material, what kind of material, and then check and monitor how long this material lasts in the pavement. Then, after a certain time, for sure, they can improve their activity with no additional cost. After that, we can talk also about new materials.
It's a kind of it's a problem of efficiency. Is to
Yes.
use what we have efficiently and then think on new materials.
Yes, we must. I would start learning from our mistake. So we must check the pothole, we must repair the pothole, but then we must record the material we used and we must monitor what happened in that road. So that is the starting point.
Right. And Andrea, again, it's I was thinking about cement on asphalt. I hear some questions on WhatsApp as well, and I'm going to deliver you this question. We can talk later. Indeed, we can. Indeed, I'm gonna invite you for a lecture specific Republic of Engineer about
Yes,
this
yes, thank you.
STEM. Okay,
I
and
I am available every time if you want to. Also, a support for your lecture with the student during the academic year. So you just write to me, and if there are some questions, I'll be happy to answer to the question of people that are interested in. Uh, yes.
okay, okay. Thank you very much. So
Well,
uh,
welcome.
we have now Professor Venâncio. That's a great French class, that comes speak with us about
Bye
material as
bye.
well. And then now I brought sadly I say goodbye, but happily I have to thank you very much for have coming give us your speech here on the Oxford Congress and your bright full speech.